Now we're going to be talking about polynomial functions, so it's lots of new vocabulary. Make sure you have your notes ready. Okay, so a monomial, we're going to start with monomials. Everything is built off of monomials. So a monomial, you have a real number, a variable, or a product of real numbers and variables, and that gives us a monomial. So you notice here, remember product means multiplied. So here I have a 4 and an x multiplied, and that's a monomial. Just a 5, it's a real number, so that's also a monomial. In this third example here, I have lots of things multiplied, but it's all multiplication, so it's still a monomial. Binomial, prefix bi means 2, so we're going to be taking two monomials and separating them by addition or subtraction, and then we have a binomial. Trinomial, prefix tri means 3, so now we're going to have three different terms, and we're going to have them separated by addition or subtraction, and each one separately is a monomial, and then when you put them together, you get a trinomial. Now, polynomials are, all of these are considered polynomials. So polynomials are a monomial or a sum of monomials. So all three of these are polynomials. Poly means many, okay? So many monomials together, or one monomial still considered a polynomial. So just like most of the functions we've talked about before, we always have a standard form. So if you can recall, our standard form of quadratic is ax squared plus bx plus c. We always arranged it so that the x squared was first and then just the linear term with a power of 1 here. Now that's because we always arrange things in descending order from the degree. So when you see this word degree, you should be thinking exponents or powers on the variable. So we always want to go from greatest to least whenever we're putting a polynomial in standard form. Also notice here some of the other stipulations is that n cannot be a negative integer, so our powers here have to be positive numbers. And then our coefficients here that are in front of the x terms all have to be real numbers. So when we're talking about polynomial functions, it's all real numbers as the coefficients. So here we have an example of a polynomial function. We denote it as p of x just to represent that it is a polynomial function. P of x works just like f of x would. Now this is a cubic polynomial, so we're going to start with the cubic term, and then we're going to descend from there. Now you don't always have each term represented, but in this one, just to show you what each one is called. So this would be the cubic term, and then descending one power would be the quadratic term, and then we have the linear term where the power is just 1, and then you always end with the constant term. Alright, so now we're going to be looking at how to classify polynomials by the degree of the polynomial. Now when I say the degree of the polynomial, I'm talking about the largest degree of any of the terms inside that polynomial. So what is the largest exponent? What is the largest number of the exponent? So let's go ahead and fill in this chart here. If you notice, whenever we have a 0 degree, that's our constant term. For example, the number 6, there's only one term there, and therefore it's going to be a monomial. Okay. Now here, I know that I'm calling it a linear function, therefore that means that the highest degree has to be 1. Here, x plus 3, well, that has two terms, so it's a binomial. If the degree is 2, we call that a quadratic function. For example, 3x squared is just one term, so it's a monomial. If we are calling it a cubic function, well, that means that the highest degree is 3. For example, here, in this example, there are 3 terms. 3 terms means I have a trinomial. Alright, if our highest degree is 4, then we have a quartic function. So that's a new vocabulary word. So highest degree being 4, it's quartic. Okay, quartic. So for example, here we have 2 terms, x to the 4th plus 3x squared. There's only 2 terms, therefore this is going to be a binomial. And then if our highest degree is 5, we're going to call it a quintic function. Quintic, okay? So quartic and quintic, 2 new vocabulary words that we haven't looked at before. And here I have 4 terms, Now, if there's 4 terms, we don't have a special name like these other ones. We just say a polynomial of 4 terms. So anything greater than 3, we don't have a special name, so you just name it as polynomial of however many terms, okay? So if there's 7 terms, it's a polynomial of 7 terms. Now, as far as classifying it by degree, we're going to only go up to 5. So we're only going to talk about linear, quadratic, cubic, quartic, and quintic. All right, so now we're going to be classifying each polynomial by the degree and by the number of terms. So it's important to remember that it needs to be in standard form, and you also have to make sure you have all like terms combined. So for the first one here, I need to combine the like terms, which are these guys. So I'm going to get negative 2x plus 5. So classifying it by degree, well, the highest degree is 1. That's linear. So this is going to be a linear function. And by number of terms, well, there's 2 terms here, so it's a linear binomial. All right, now this second one here is also not in standard form, and I have like terms that need to be combined, so rewriting it in standard form. Notice I have no cubic term, but that's okay. You don't have to have each one represented. So by degree, the highest degree here is 4, so that's quartic. And by number of terms, well, number of terms, 1, 2, 3, 4, so it's a quartic polynomial with 4 terms. Remember, anything bigger than 3, we don't have a special name for it. Now this last one, I need to combine like terms, or I'm sorry, distribute first. So this is 30x cubed minus 10x squared. It's already in standard form for me. Highest degree is 3, so that's cubic. And then there are 2 terms, so it's a cubic binomial. So the degree of a polynomial will affect the shape of the graph, okay? So depending on the degree, so if it's quadratic, if it's linear, if it's cubic, that will determine the different number of turning points in my graph. Now when I say turning points, I mean where the graph changes direction. So you know, maybe it's going up, and then it goes down, and then it goes up, okay? So here I have 1, 2 turning points, okay? So we are going to be able to figure out if I have 2 turning points, well then what is the degree of the polynomial? Now the degree also affects the end behavior. Now when I say end behavior, I'm talking about what's happening at the far left and the far right of my graph. So that would be here and that would be here, okay? So what's going on at the ends of my graph, and the degree will also help me determine that. Alright, so there's 2 things that determine the end behavior of a graph. The first is the degree. So the degree is the most important thing. If the degree is even, then the ends of the graph will go in the same direction. If the degree is odd, then the ends of the graph will go in opposite directions. Now, how we know which direction depends on the leading coefficient. Now, this term leading coefficient means the number in front of the highest degree term. So it should be the number at the very front of your function if it's in standard form. Okay? Now, I want to try to relate this to something you already know. Alright? So, I want you to recall. If I give you this function, and I ask you to graph that, hopefully you would know that that is going to be a line, right? It's a line with a slope of positive 2. Now before even graphing that, I should know that a positive slope means my graph should tilt this way whenever I graph it. Now take a look at how this relates to what we just said. That the degree is 1, so that's odd. And since the degree is odd, the end behavior of the graph goes in opposite directions, which it does in this case. In this case, it goes down on the left and up on the right. Now, looking at the leading coefficient here, which is a positive 2, the positive 2 tells me I have a positive slope. But positive 2 also tells me that I'm going to be down and then up. So the leading coefficient is positive, so then it's down and up. Alright, looking at another function that should be familiar to you, let's look at this. Negative 3x squared minus x plus 1. Now, this is a quadratic function because the largest degree is 2, so this is a quadratic function, which we hopefully know means that it will be a parabola. Now, since it's a parabola, we look at our leading coefficient, which is negative, and we should know that when I go to graph this guy, it should look like this. Now, the highest degree is 2. Even degrees means same direction, and aren't these going in the same direction? Yes, they are. Now, the leading coefficient's negative, which means we go down. So down on the left, down on the right. Okay, so this relates very closely to what you already know. We're just going to be taking this and looking at higher degree polynomials. All right, so now we're going to be looking at the end behavior of the graph. So first you want to make sure that your function's in standard form. So here you want the highest degree first, and then it's going to decrease. So this is already in standard form. And then you want to check to make sure what is your degree. Well, this is a degree of 3, which means it's a cubic function. Now, degree of 3, remember, means that it will either be down on the left side and then up on the right side, or it's going to be up on the left side and then down. It's going to be opposite directions, okay? Now, to decide which it's going to be, you look at the leading coefficient here. So since the leading coefficient's 4, it's positive, that means it's this first choice here, okay? So we're going to be going down on the right-hand side, and then we're going to be going up on the left-hand side, okay? Now for the second example, we need to make sure it's in standard form, which it's not. So I'm going to rewrite it in standard form. We put the highest degree first, which is this guy. That is the tricky part. Make sure it's in standard form or else the whole question could be wrong. All right, now since the highest degree is 4, it's even, so I know that it's either going to be up, up, or down, down, okay? So to decide, you look at the leading coefficient. So the leading coefficient's negative, so then this kind of acts like a parabola where the leading coefficient's negative, so that means we're going to be down on the right, and then we're going to be down on the left, okay? It's going to be the same because it's an even term, and I know they're both down because the leading coefficient is negative. Here are the graphs of those functions just so you can double check and see that we were correct. We're going to go in opposite directions, down and then up, and then here, same direction, both down. So turning points happen in our function whenever the function starts to change its direction. So if it's increasing and then it starts to decrease, or vice versa, that's when I'm going to have a turning point. Now, I want you to think of, when you think of an odd function, I want you to relate back to our linear function. So remember, that's a degree of 1. And if you notice here, this function is just constantly increasing. Or if it had a negative slope, it would be constantly decreasing. So whenever the degree is 1, we have no turning points. And remember, that's odd. Now, if the degree is 2 and we have a quadratic function here, notice how it's decreasing and then it starts to increase. So we have 1 turning point there. So whenever we're looking at a function, we have a maximum amount of turning points and a minimum amount. Now, linear and quadratics are going to give us our minimums for the odd and even function. Now, if it's a higher degree, for odd it's n-1 and even it's n-1 also. Now, n-1 just means take the degree and subtract from 1. So here I have a cubic function, and notice it is increasing and then it continues to increase. So there is 0 turning points for this cubic function. So it's achieving the minimum amount of turning points for an odd function. This is also a cubic function, and if you notice, it's increasing. 1 starts to decrease, 2 starts to increase. So there's 2 turning points there, and it's still going to be a cubic function because remember, n-1, since it's cubic, that's going to be 3 minus 1, which is 2, which is just what we said. So this is going to help us figure out what the graph of the function should look like. So if I gave you a quartic function, let's say I gave you y equals x to the 4th minus 3x squared plus 1. Notice that doesn't have a cubic term, but that's okay. It doesn't have to have all terms. If I wanted to figure out the turning points, well, the max amount is going to be n-1, so that's going to be 4 minus 1, which is 3. And the min amount, since it's even, will just always be 1. Alright? So the max would be 3 and the min would be 1 for this quartic function. Now we wouldn't really know which one it is, 3 or 1, until we graphed it. All right, so go ahead and answer these 3 questions for these 2 functions. Make sure you put it in standard form before you answer them. And for turning points, remember you can have a max or a min value.